The AWS US-EAST-1 outage that took out the internet. A DevOps Postmortem. It was 7:30 PST on December 7th, 2021, when the digital floor just dropped out. In an instant, the backbone of much of the modern internet began to buckle under a massive surge of automated scaling activity within the US-EAST-1 region. This wasn't some minor glitch or a localized blip. It was a systemic collapse. As the internal networks choked, the cascading failures didn't just hit one company, they hit everyone. Services started hemorrhaging, APIs stopped responding, and for several hours, the infrastructure that powers our daily lives became a ghost town. The scale was staggering, affecting countless third-party platforms simultaneously. Imagine the sheer chaos of engineers watching their dashboards go dark, while the very tools they needed to diagnose the problem were being strangled by the congestion itself. It was a perfect storm where the system literally blinded its own operators, turning a routine automation into a full-scale blackout. Imagine your entire infrastructure is built on top of someone else's house. That was the reality for millions of companies relying on Amazon Web Services. On December 7, 2021, that house didn't just have a leak. The foundation practically buckled. Specifically, things went sideways in the US-EAST-1 region, a massive hub where thousands of businesses host their core operations. At exactly 7:30 PST, an automated scaling process intended to grow an internal service backfired, triggering massive traffic spikes that choked the network pipes between internal systems and the main public web. This wasn't just a minor glitch, it created a cascading failure that crippled numerous APIs and essential services. When the backbone of the internet starts stuttering because of its own automation, every company downstream feels the heat. It was a perfect storm where the congestion actually blinded the monitoring tools, leaving engineers flying blind while trying to navigate a digital fog. It was December 7, 2021, and for most of us, it started like any other morning in the cloud. The infrastructure was humming along, handling millions of requests across the globe with the usual grace of a well-oiled machine. Then, at exactly 7:30 PST, the invisible gears began to grind. An automated scaling routine, something designed to make the system more resilient instead, triggered a massive surge of connection activity within an internal service. It wasn't just a small hiccup, it slammed into the network hardware connecting the internal systems to the main AWS network. This sudden spike created a bottleneck that didn't just slow things down, it choked the pipes entirely. What started as a routine automation task became a localized traffic jam that began to bleed outward, quietly setting the stage for a massive, multi-service collapse that would soon leave parts of the internet in the dark. It started at 07:07 PST on December 7th. At first, it wasn't a bang, it was just a ghost in the machine. An automated scaling routine for an internal service kicked off. But instead of expanding capacity, it triggered a massive surge of connection activity. This surge slammed into the internal network boundary of the US-EAST-1 region, creating a bottleneck so severe it choked the pipes between the internal and main networks. Within minutes, the cascading effect began its crawl. Engineers watching the dashboards saw APIs start spitting out errors, effectively blinding them. The irony was brutal. The very congestion that broke the infrastructure also crippled the monitoring systems and management tools needed to fix it. By the time the morning rolled around, thousands of companies downstream were feeling the heat, staring at failing connections while the engineers inside the house were fighting through a digital fog. It started at 7:30 PST with something mundane and automated, scaling routine for an internal service. But instead of just adding capacity, it triggered a massive surge of connection activity that slammed into the internal and main network boundaries like a tidal wave. This wasn't just a local glitch, it was a systemic chokehold. As the congestion built, it began to bleed outward, crippling the core infrastructure that keeps the lights on. By the morning, the fallout had hit the critical nerve centers, the APIs used by developers, and the monitoring systems meant to alert them were both failing. It became a hall of mirrors where the tools we needed to diagnose the fire were being smothered by the smoke. The failure didn't just sit there. It cascaded through countless third-party companies, effectively blinding anyone trying to fight back until the offending traffic was finally throttled and capacity could be clawed back. So, what actually broke the gears? It wasn't some external cyber attack or a rogue human clicking a button at the wrong time. At 7:30 PST on December 7th, an automated scaling routine for an internal service kicked off. This triggered a massive surge of connection activity intended to scale resources, but instead it slammed into the hardware like a freight train. The sheer volume overwhelmed the specific networking devices sitting between the internal infrastructure and the main AWS network in US-EAST-1. Because this bottleneck happened deep within the plumbing, it created a blind failure mode. The resulting congestion choked the monitoring systems and crippled the very APIs the engineers needed to see what was happening. They were essentially flying a plane in a storm where all the cockpit instruments had just gone dark. When your core management layer loses its ability to talk to the network, fixing the problem becomes a desperate game of guessing in the dark. When we talk about blast radius, most people think of a localized fire. This wasn't a spark, it was a structural collapse. On December 7, 2021, a routine automated scaling action triggered massive congestion within the internal US-EAST-1 network. By 7:30 PST, the gears began to grind, and what started as an internal hiccup morphed into a full-scale blackout for anyone relying on those specific cloud resources. Because the congestion blinded the very APIs needed for diagnosis, the outage didn't just hit one service, it cascaded across countless third-party companies that depend on AWS infrastructure. For several hours, the internet felt like it was shrinking as core systems went dark simultaneously. It wasn't just a technical failure, it was a systemic paralysis where the primary tools used to fight the fire were the first things to burn out. By 7:30 PST on December 7th, the first tremors hit. Automated scaling activity triggered a massive surge of connection traffic that choked the bottleneck between the internal AWS network and the main infrastructure in US-EAST-1. The problem wasn't just that things were breaking, it was that the congestion effectively blinded the engineers. Because the overload crippled the monitoring systems and the very APIs needed for troubleshooting, the team was essentially fighting a ghost in the machine. They weren't just dealing with a service failure, they were battling an infrastructure blackout, where their primary diagnostic tools had vanished into the noise. It took hours of grinding through the fog until they could finally identify the offending automated activity. Once they throttled that specific traffic, the network capacity began to breathe again, allowing services to slowly crawl back to life throughout the afternoon. The solution wasn't some elegant piece of code. It was a desperate game of whack-a-mole against their own infrastructure. Once engineers identified the specific automated scaling activity choking the pipes, they had to manually throttle that traffic to breathe life back into the system. By throttling the offending activity and restoring network capacity, they began the slow crawl toward recovery throughout the afternoon of December 7th. But fixed didn't just mean getting the lights back on, it meant ensuring this ghost wouldn't return. AWS committed to structural changes designed specifically to prevent this type of congestion trigger from ever hitting the core again. They also overhauled their internal network observability. The goal was simple: ensure that if the primary networks get slammed, the internal control planes stay visible enough for someone to actually see what's breaking before the entire internet goes dark again. Look, if there's one thing this disaster taught us, it's that your internal systems aren't invisible just because they aren't customer-facing. When that automated scaling triggered at 07:30 PST, it didn't just break a service. It choked the pipes connecting the internal infrastructure to the main network. The real nightmare was how that congestion blinded their own eyes, the monitoring and APIs, to diagnose the mess were buried under the same traffic jam. It's a brutal reminder that when your management plane shares a fate with your data plane, you're flying blind the moment things get hairy. We have to build for the scenario where the tools we use to fix the fire are the first things to melt in the heat. Resilience isn't just about uptime, it's about ensuring that even when the primary systems buckle, the telemetry stays alive so someone can actually reach into the machine and turn the dial back. That's how Amazon Web Services turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.